Every device on a network needs an address, for the exact same reason every house needs one. If the mail carrier does not know where you live, your letter never arrives. On a network, that address is the IP address. Let's decode what it actually is. I'm Tessa, and this is Envision Decoded. An IP address, short for Internet Protocol Address, is a unique label that identifies a device on a network. It is how data knows where to go. Every phone, laptop, server, and smart device gets one. There are two versions you will hear about: IPv4, the original, and IPv6, the newer one built to handle a much bigger internet. Without IP addresses, the internet simply could not route anything. When you load a web page, your request has to find one specific server out of billions, and the reply has to find its way back to your one specific device. The IP address is what makes that possible, so understanding it is the foundation for almost everything else in networking. Let's start with the format. A classic IPv4 address looks like this: 192.168.1.10. It is 4 numbers separated by dots. Each number is called an octet, and each one can range from 0 to 255. Under the hood, those 4 octets are really 32 ones and zeros, 32 bits, which is why you will hear IPv4 called a 32-bit address. An IP address actually has 2 parts. The first part identifies the network, and the second part identifies the specific device or host on that network. Think of it like a street name and a house number. A value called the subnet mask decides where the network part ends and the host part begins. We will go deep on that in the subnetting episode. Now, private versus public. Some address ranges are reserved for private use inside your own network. There are exactly 3. Anything that starts with 10, the range from 172.16 to 172.31, and anything that starts with 192.168. Your laptop almost certainly uses one of these 3 right now. They work inside your home or office, but they are not valid on the open internet. A public address is simply anything outside those 3 private ranges. It might look like 203.0.113.5. That is the kind of address the internet actually routes to. So how do you get from one to the other? Your traffic passes through your router, which swaps your private address for your network's single public address, using a process called NAT. The internet never sees your private address, it only ever sees your router's public one. So why does IPv6 exist? 32 bits gives you about 4.3 billion possible IPv4 addresses. That sounds like a lot until you count every phone, laptop, server, camera, and smart bulb on the planet. We ran out. IPv6 fixes this with 128-bit addresses, written as 8 groups of hex separated by colons. The number of addresses it provides is so large it is effectively unlimited. And how does a device actually get its address? 2 ways. Static, where someone types the address in manually, common for servers that must never change. Or dynamic, where the device is handed an address automatically when it joins the network, using a process called DHCP. So, to decode it. An IP address is a device's address on a network. IPv4 is 4 octets, each 0 to 255, 32 bits total. Addresses split into a network part and a host part. Private ranges 10, 172.16 to 172.31 and 192.168 stay inside your network. Public addresses face the internet, and NAT bridges the two. And IPv6 exists because we simply ran out of IPv4 space. If that made IP addresses click hit subscribe so the rest of this Network Plus series finds you, and give it a like if it helped. The full playlist is linked below. Next time, we tackle the one thing everyone dreads: subnetting made simple. I'm Tessa, this was Envision Decoded. See you in the next one.